At home, you must have seen that especially in the summers and the rainy season, your mother is very careful about keeping things in the refrigerator. Why so? Due to heat and humidity, the food gets spoiled, the taste changes. And what happens if milk is left outside? It starts curdling. Even for setting curd, what she does? She puts a little of curd in the milk, and after 5 to 6 hours, the milk has set into curd. What is all this? Okay, you take sugar, put it in a pan, after some time it turns black. Not only this, very often the gates and the grill is painted. Why is it painted? What are all these I am talking about? What I am talking about is the chemical changes. What is a chemical change? A chemical change is the change during which a new substance is formed. Now, how a new substance is formed? I will tell you. Then it is irreversible. We cannot change it. Just like when ice melts, it becomes water. But on freezing, water can change back to ice. However, chemical changes cannot be reversed. They are irreversible. Third, it involves energy. Either energy is absorbed or it is released. So, these are some of the things that take place when a chemical change is taking place. Not only this, there can be a change of color, there can be a change of state, there can be change of taste, and so many things happen. Now, why do these chemical changes take place? That is what we are going to understand today. Chemical changes are there because some kind of reaction has taken place. A chemical reaction has taken place. What is a chemical reaction? Whenever two substances come in contact with each other, they undergo a change and new substances are formed. Now, just imagine if you burn a matchstick, there is a flame and then some ash is produced. Second type of reaction is in which a compound breaks down. For example, these reactions are called decomposition reactions. For example, if you heat calcium carbonate, what will you get? CaO plus CO2. So, here the compound has broken down. You pass electric current through water, what will happen? You will get hydrogen and oxygen. So, here also what has happened? Water has broken down into hydrogen and oxygen. Ammonia, this of course is a reversible reaction. A reversible reaction is written like this, half arrow in one direction, half on the other. What we get is nitrogen plus hydrogen. All these reactions are decomposition reactions. Silver chloride, silver plus chlorine. Same is true for silver bromide. Now, when ferrous sulfate is heated, what we get is ferric oxide plus sulfur dioxide plus sulfur trioxide. Right? Now, ferrous sulfate is green in color, but ferric oxide is not. Not only this, there is also a pungent smell, that of sulfur dioxide. So, there is change of smell also. When we heated lead nitrate, what did we find? Brown fumes coming. These brown fumes are that of nitrogen dioxide. So, the equation is like this: lead nitrate, heat, gives us lead oxide plus nitrogen dioxide plus oxygen. So, now because it is NO3 twice, so nitrogen is 4, here also nitrogen is 4, oxygen becomes 12, and here we have 2, 8, 8 plus 2 10 and 2 12. So, equation is balanced. So, in this way we find that some compounds they break down on heating or under other circumstances, and then they produce new compounds. So, such reactions in which there is a breakdown are called decomposition reaction. So, I took different metals like say zinc, aluminum, iron, we can even take magnesium, and if possible copper and silver. So, at this moment I have with me zinc, iron and aluminum, and then poured hydrochloric acid over it. What do we find? There is a release of a gas, but the rate of reaction is not same. It was much more vigorous in the case of zinc and much slower in the case of copper. In fact, hardly any reaction. So, how does this reaction take place? Taking the case of zinc plus hydrochloric acid, what we find is that a salt is formed, zinc chloride plus hydrogen is released. What has happened? Hydrogen has been removed from the hydrochloric acid. It has been displaced by zinc because zinc is more reactive. Similarly, in the case of sulfuric acid, zinc sulfate and hydrogen will be produced. In both the cases, the hydrogen has been displaced. Such reactions are called displacement reaction. Now, normally when acids and metals react, then metals are able to replace hydrogen and they produce salt and hydrogen is released. Now, this is the case where only one element, or you can say one type of ion is displaced. Sometimes there is a displacement, or there is a, you can say it in simple language, change of partners. Now, how is that? If you will pour sulfuric acid into barium chloride, what you will get is barium sulfate plus HCl. This is white precipitate. Now, here what has happened? The reactants have changed their partners. Barium and sulfate have joined together, hydrogen and chlorine has joined together. So, there is a displacement, or you can say replacement of ions. It is the ions that get displaced, and this is called double displacement reaction. Now, what happens when an element combines with oxygen, like in this case, or this case, or this case? Every time what we got was an oxide. Now, what has happened? There is addition of oxygen. This is called oxidation. So, we can say here carbon, magnesium or calcium has been oxidized. Oxidation is not only addition of oxygen, removal of hydrogen is also oxidation. So, either addition of oxygen or removal of hydrogen means oxidation. There is another complementary reaction, reduction. Reduction is addition of hydrogen or removal of oxygen. This is reduction. For example, N2 plus H2 is equal to ammonia. This is reduction. Now, another aspect. Now, when CuO, copper oxide, is heated with coke, what we get is copper and carbon dioxide. So, what has happened? Oxygen has been removed from the oxide, and so what will we say? Is it oxidized or reduced? So, we will say because there is removal of oxygen, so we will say it is reduction. So, copper oxide has been reduced to copper. This is reduction. And what has happened to oxygen? It went and combined with carbon. So, this was, we can say, carbon has been oxidized. Carbon oxidized, CuO reduced. Even in the case of iron, same thing happens. Now, this method is also used for extracting metals. When we are manufacturing iron or zinc, then we heat it with coke to convert oxides into their metals. When we will be doing metals and non-metals, we will study this more in detail. So, actually speaking, oxidation and reduction goes hand in hand. And when oxidation and reduction go hand in hand, the reaction is called redox. So, we can say that oxidation and reduction go hand in hand. They happen simultaneously. So, the fifth type of reaction is the redox reaction. There are some more examples of displacement reactions. And this can be shown with very simple experiment like I just showed you. We take copper sulfate solution. Copper sulfate is blue in color as you saw, and then we put iron nails in it. After some time, what we found? Iron nails were brown in color. Why? Copper got deposited on them because iron replaced copper. So, what we got was iron sulfate plus copper, and copper got deposited on the iron nails, and ferrous sulfate solution is green. So, the solution turned from blue to green. So, actually what has happened? Iron has displaced copper from its compound. Why? Because iron is more reactive. When you will study activity series, you will find the exact order in which we place them according to their reactivity. Then you can also do that, you can put some zinc in copper sulfate. Even zinc is more reactive than copper, so it will replace copper, and what we will get is zinc sulfate plus copper, and zinc is white. So, though zinc is also slightly brown, but because copper is more reddish brown, zinc will get coated with reddish brown color. So, in these cases what we have seen is that this has been able to displace. Then if you take copper chloride and lead, what you will get is again lead chloride and copper. So, all these lead, zinc and iron were able to replace copper. Why? Because they are more reactive than copper. But if we would change the method, and if we take ferrous sulfate and put copper in it, there will be no reaction. FeSO4 plus copper, no reaction. Why? Because copper cannot displace iron, because it is more reactive. Now, say if there is a monitor in your class and he is doing very well, and a new student comes who is better than him or her in behavior, in academics, in co-curricular activities. So, what happens? The teacher decides, okay, we can make him the monitor. So, this one has displaced the old one. But if the new entrant was not so bright or was not so able to take initiative, then he will not be able to. So, just in this case, the metals which are more reactive will be able to replace, and which are less reactive will not be able to replace. Now, what is the advantage? The advantage is in the case of noble metals, silver and gold. That is why especially gold is not influenced or affected by the presence of oxygen, water or acids, because gold is comparatively a very non-reactive metal. That is why it is valued so much. If you have silver jewelry, after some time what do you find? It has turned black. Your copper ware or the things that are made up of copper, they become slightly greenish. The aluminum turns dull. Why all this happens? What is this phenomenon? That is our next topic. Why do we paint iron gates or grill? Even when we use mixie, it is advisable that we wipe it dry, and if possible also put oil on it. Why do we do this? Sometimes we galvanize metals, sometimes we electroplate them, paint them, oil them. What is all this? This is to prevent a reaction that goes on when a metal is exposed to air, water or acid or even carbon dioxide. This is called corrosion. Corrosion is loss of matter layer by layer, loss of metal layer by layer by the action of air, water, acid. Now, see, silver turns black not due to the action of any of these, but due to the action of hydrogen sulfide, which is black in color. So, all these metals are getting affected by other gases or other chemical substances. This is called corrosion, and there is actual loss of water. If you would take some iron nails, weigh them and then expose them to air and water, and after some time when they have rusted, that is, there is a dark brown powdery coating on nail, and if you rub it with sandpaper and then weigh it, you will find there is loss of weight, and the thing also gets spoiled. That is why it is very important that whenever we are using iron things, we must protect them properly. That is why we paint the iron gates, because they are exposed to air. There are many methods to prevent corrosion, like we can do oiling, we can do painting, we can do galvanizing, in which a coat of zinc is put on it. There can be electroplating, and then what also we can do is that we change metal to its alloy. What is an alloy? Alloy is a homogeneous mixture of a metal and non-metals. So, iron is changed to steel or stainless steel, copper is changed to brass or bronze. The alloys, the advantage of making an alloy is that an alloy is not easily affected by the air, oxygen or acids. It has the good properties of the metal and minus the bad ones. So, when iron is changed to steel, the chances of rusting are gone. Similarly, we have many alloys of aluminum like duralumin and all, which are used to make parts of the aircraft, because aluminum also gets corroded by the action of oxygen. It forms aluminum oxide, but interestingly enough, it also prevents further corrosion, because aluminum oxide remains outside and then the inner layers of aluminum are saved. So, this is the story of corrosion. When fat or oil gets oxidized, then what happens? bad taste, the properties change. This is called rancidity, oxidation of fats and oils. So, what is the way out? We have to prevent this oxidation. For this, we add antioxidants. These days, there is lot of focus on using antioxidants, because when these fats and oils get oxidized, they form harmful substances. Now, what happened in the two experiments that I showed you? In the first one, magnesium burnt with a bright light and then changed into ash. In the second one, when dilute hydrochloric acid was poured over zinc granules, then zinc chloride was produced and hydrogen gas was released. Now, if you are supposed to explain this, how will you say? You will say the way I said, but isn't it too long? You know, chemistry is great. In chemistry, we are not so dependent upon conventional language. We can use shortcut. And what is that shortcut? We can say that magnesium, and for burning, which gas is needed? Plus oxygen gave us magnesium oxide. You don't need to say that magnesium wire burnt in the presence of oxygen to produce magnesium oxide. And what is this called? This is called a chemical equation. How will we define a chemical equation? It is a chemical representation of a chemical reaction. So, what we have used is, we have just used the words, and whatever two compounds or two elements or one element and a compound combined with each other or reacted with each other, they are written on the left hand side. So, on the left hand side, the compounds are the ones which are initial substances. These initial substances that react with each other are called reactants. And as a result of this interaction or reaction of reactants, the substances which are produced, they are called products, and they are written on the right hand side like this. So, in a chemical equation, these are the reactants and magnesium oxide is the product. Now, what you have seen is there is a symbol of plus. Now, whenever two compounds are reacting with each other and we want to talk about more than one substance, we put a plus. In the second case, dilute hydrochloric acid was poured over zinc granules. So, what happened? Zinc plus hydrochloric acid and what did it give us? It gave us zinc chloride and hydrogen. Now, in these cases what we see is that here we started with magnesium, a solid, oxygen, a gas, and what did we get? A solid. Here also we started with solid, that is zinc, hydrochloric acid is liquid, and what we got was again a solid and a gas. So, what is the conclusion? That whenever a chemical reaction takes place, there is a change of state. Another thing that happened was evolution of a gas. in many cases the temperature also changes. For example, if you put a drop of perfume on your palm, after evaporation you feel cold, isn't it? Similarly, if you pour water in sulfuric acid, there will be lot of heat generated. You put water in quicklime, lot of heat will be generated. So much so, even when you are exhaling a part of respiration, if you do this, you will feel a little warmth on your palm. Why? Because heat is being released. So, heat is either released or absorbed. In other words, there is change in temperature. Now, going back to our first experiment, magnesium is a metal, so it has a luster, but after burning it was white in color. Zinc is slightly brown in color, hydrochloric acid is yellow, and what we got was a colorless gas. So, that means there is also change in color. So, these are the 4 changes that can take place when a chemical reaction is taking place. Now, going back to our equation, here we were able to use a word equation, and that is a short form of talking about a chemical reaction. Can it be shorter? Yes, it can be. In chemistry, we do not have to depend upon conventional language. Chemistry has its own language. So, what we do? We can use symbol and formulae. Let us replace these words with symbols and formulae. Now, in the case of magnesium, the symbol is Mg, capital M, as the first letter is always capital and second letter is small. So, Mg plus symbol of oxygen is O, and in the molecular formula it is written as O2. So, O2 leads to the formation of magnesium oxide. What is the formula? As both oxygen and magnesium have 2 valency, the formula will be as if there is only one atom of magnesium and one that of oxygen. So, it will be MgO. See how small it has become? Now, in the second case, zinc is Zn, hydrochloric acid is HCl, and what we get is zinc chloride plus hydrogen. Straight, no need to explain too much. From here we move on to the next step, that is balancing of the chemical equation. First of all, why balance? It has been observed that mass can neither be created nor destroyed, it remains same, which means the number of atoms of a particular element in a reactant will always be ultimately equal to the number of atoms of an element in the products, which means both sides have to be equal. It is something like a balance. You want to buy a vegetable, what do? You tell vendor that I want 1 kilogram of potato. What he does? Puts potato on one side and then the weight on the other side and keeps on changing till both are equal. Sometimes he even says this, that okay, I can't remove or add one full potato, but what I will do is I will reduce the size to make it equal. Now, we may not do exactly like that in balancing equation, but we will do something of that kind. There is a proper method, it is not as if you can do haphazardly. So, what we do here is we will take the case of some reactions. In these reactions what we find is that automatically everything is balanced. For example, if you put water in quicklime, of course lot of heat will be released, that is what we do before whitewashing. So, in calcium oxide, when it combines with water, what it forms is calcium hydroxide. Now, if we count the number of atoms in an element, say in the case of calcium, these are the reactants, these are the products. How many calcium atoms are there? 1 in reactant. Here also 1. Hydrogen, how many hydrogen atoms in water? 2. Here also 2. Oxygen, 1 atom is here, 1 atom is here. So, 2 and 2, which means it is balanced. So, in this case we do not need to balance it. Let us take another case. Instead of hydrochloric acid, if we pour sulfuric acid on zinc, then what happens? Zn plus H2SO4, ZnSO4 plus H2. The sulfate has been, zinc has removed the hydrogen. So, no problem, it is balanced. But in all reactions, it does not happen like this. In many cases, they are not balanced. For example, first let us take some simple cases. Now, what happened when magnesium burnt? It was Mg plus O2 is equal to MgO. So, although the number of atom of magnesium was same on both sides, but here oxygen atom was only 1. So, what do? We take 2 molecules of magnesium oxide. So, that makes 2 oxygen atoms, but then magnesium atoms have increased to 2, while here they were only 1. So, we put 2. Same is true for calcium oxide, or when hydrogen and oxygen combine, they form water. Now, here oxygen atoms are 2, but here there is only 1. So, if there are 2 molecules of water, we will get a balanced equation after we have also taken 2 molecules of hydrogen. So, here in these cases what we found that we have always put the prefix in front of the compound. Why couldn't we do something like this? Then also it would be equal, but we can't do this because this will make it hydrogen peroxide. This is not water, the formula will change, the atmosity will change. So, we can only change the number of molecules or the number of atoms of an element or a compound. So, that is why always the number will be written in front. Iron plus water gives us ferric oxide and hydrogen. Now, how are we going to do it? So, this time I will tell you the steps. First step is that we put boxes around the element like this. In the second step, we write down the number of atoms of every element. For example, we have iron, we have hydrogen, we have oxygen, here are the reactants, here are the products. 1 atom of iron in reactant and in product 3. Hydrogen 2 and here 2. Oxygen 1 and 4. So, this will be our second step. After we have done this, then what we will do is we will take up that element which has maximum number of atoms. Now, which one has maximum number of atoms? Oxygen. So, first of all we will try to balance the number of oxygen atoms. So, third step will be balance the element with maximum number of atoms. So, in this case what we will do is we will take 4 molecules of water. So, this will make 4 atoms of oxygen here, 4 atoms of oxygen here, right. In the fourth step, we move on to the next element. Now, by taking 4 molecules of water, hydrogen atom has become 8, but here it is only 2. So, how many molecules of hydrogen we need to take? Again 4. Take second element. Next is the third element. Now, we come back to iron. Iron, here there are 3 atoms and here we will take 3. Balance the third element. Finally, we will just check all the atoms whether they are equal on the right hand side and the left hand side. So, here now what is the situation? In reactants, iron is 3, product also it is 3. Hydrogen is 8, here also it is 8. Oxygen is 4 and there also it is 4. So, the equation is balanced. So, if we move like this, then we will be able to balance the equation. Now, as in this method, we try again and again. This is called hit and trial method. So, by this method, we can balance the equation. Now, in this equation, we did not come to know about the state of matter. In some cases, we can even show the state of matter by using the symbol S for solid, L for liquid and G for gas, just the first letter. So, here for iron we can write down S, for water we will write down liquid L, for again ferric oxide S and for hydrogen G. For release of oxygen, we can put an upward pointing arrow, and if it is a precipitate, which means if some solid has settled down, then we use the word PPT and a downward pointing arrow. So, if we write an equation like this, we even come to know about the state of matter. In some cases, there are some special conditions for a chemical reaction. For example, the presence of heat, a specific temperature or pressure or sunlight. Now, the typical example is that of reaction of photosynthesis. Now, what happens in photosynthesis? There is carbon dioxide plus water and there is sunlight. So, this condition we can write down on the arrow, and what we will get is glucose plus water plus oxygen. Even in the case of silver chloride, when it is exposed to sunlight, it decomposes to silver and chlorine like this, AgCl, and here we will write down sunlight, and what we get is silver and chlorine. Silver bromide also reacts similarly. But in some cases, what is required is the pressure. For example, when hydrogen combines with carbon monoxide at 340 mm pressure, what we get is CH3OH, methyl alcohol. But without pressure, this reaction will not take place. So, it is mandatory that we write down pressure on top of the arrow. Another example is that some reactions take place when heat is there. There is an increase in temperature. For example, for preparation of oxygen, what we do is we strongly heat potassium chlorate. So, what we get is KCl plus O2. So, we will balance it like this. So, we will write here heat. Some reactions even need a catalyst. Now what is a catalyst? Now two of your friends are fighting and one does not take part, but either tries to separate them or tries to create peace or says, okay, now you must give it to him. So in the first case, the first friend was trying to reduce while the other one was trying to increase the fight. Now same is true in the case of chemistry or chemical reactions. Some chemicals, they don't take part in the reaction, but they can change the rate of reaction. Such chemicals are called catalysts. So it's good to write the definition of a catalyst. It is a chemical substance that changes the rate of reaction without taking part in it. So it is like a influence. So this is how they have a catalytic effect on your life. The environment, the atmosphere also acts like a catalyst. There is another way of preparation of oxygen, that is, if you heat KMnO4 and H2SO4 in the presence of manganese dioxide, what will happen? It will form K2SO4, MnSO4 and oxygen. But manganese dioxide will remain just like that, but it will increase the production of oxygen. So we can say that it is a catalyst. So here manganese dioxide is acting as a catalyst, and a catalyst can also be written on top of the arrow. The temperature specificity, the pressure specificity, presence of sunlight or a catalyst can be expressed on the arrow, and that will be a complete representation of a chemical reaction. Now the chemical reactions can be of many types. In some, the two elements or an element and a compound, they just add up, combine. In others, a compound may just break, decompose. In still others, there may be a change of partners or the ions, to be more precise. So what we are going to study today is the types of chemical reactions. Types of chemical reactions. The commonest one is the combination reactions. Now you burn coal in air, what will happen? Coal is carbon, C plus O2, what you get? CO2, carbon dioxide. So what has happened? The two have just joined together, right? Similarly, sulfur will give us sulfur dioxide. So these are simple combination reactions. Another one, CaO, that is quicklime plus water, will give us CaOH twice, which means it is not just the elements that can combine, even the compounds can combine with each other. How is water formed? Which elements are present in water? Hydrogen and oxygen. So H2 plus O2 gives us water. Let us balance it. So 2 molecules of hydrogen and 1 molecule of oxygen give us 2 molecules of water. In all these cases, what we are having is a simple combination reaction. You can take some quicklime and add water to it. What you will get is calcium hydroxide, a base. So if you will put a red litmus paper, it will turn blue. So you will know that from quicklime and water, you have got lime water, which is just addition of quicklime and water. These type of reactions are called combination reactions. In the combination reactions, sometimes heat is released. For example, if you burn carbon, heat is released. If you burn methane, then also heat is released plus heat. These type of reactions in which heat is released are called exothermic. Now, when you add quicklime and water, or you can say when you add water to quicklime, then also it seems as if it is boiling, and if you touch it, it will be very hot. So, lot of heat is released. So, that is also an exothermic reaction. CaO plus H2O is equal to CaOH twice. If you want to dilute sulfuric acid, what will you do? Will you add water to sulfuric acid? Try it, you will be in difficulty. It will start boiling and there is every possibility that some drops may come on your face. So, usually the precaution is that we add sulfuric acid to water, and that also very slowly. So, that also is an exothermic reaction, H2SO4 plus water. So, all these reactions in which heat is released is an exothermic reaction. So, we can write it like this: heat released. Are there any cases in which heat is absorbed? Many, because when we heat a particular compound for a chemical reaction, heat is being absorbed, and such reactions are called endothermic. Heat absorbed. Endo means inside, exo means outside. So, these are the reactions in which there is involvement of heat.